Hello, my name is Bruno Rodrigues. I will talk about SC-Flare, which is a cooperative DDoS signaling approach based on smart contracts. As introduction, we have rise in distributed denial of service attacks, and this happens mainly because the number of IoT devices are growing, and not only they are growing, but they are most of the times not secure at all. And this is basically because they are not possible to be secured due to their hardware constraints, or they are just misconfigured by the users. As a side effect, we have that botnets are exploiting the insecurities of those devices. We have in the beginning Storm, Zeus, and more recently we have the Mirai botnet, and also the many variants of the Mirai botnet. And as a side effect of this, we have that the large-scale DDoS attacks, they are increasing the number and the frequency of attacks, and also the traffic scale, the volume of traffic in which those attacks can generate. It is easy to learn how to use those tools, how you can gather devices to create a botnet. There are many tutorials available. On the other side, you have also an easiness to hire DDoS attacks using the so-called DDoS booters, which are services to generate a DDoS as a service. And it's hard to be liable of those DDoS attacks, and this creates a favorable environment for people generating DDoS attacks. If we think on the defending side, you have that centralized defense systems, the so-called in-house defense system. They are easily overloaded by those large-scale DDoS attacks, and in a situation that increasing the hardware and the software available, it's not an ideal solution, because the attacking side can increase in a scale that is much higher than your capacity in a centralized defense system to increase your defense. And in this situation is ideal distributed defense, in which you can likewise coordinate and distribute the defense, because then you can reduce the burden of the detection of attack and also the mitigation in a single domain, distributing this burden to different domains. And also different domains means that they have different systems, different detection capabilities, and also different mitigation capabilities, with a benefit that you can possibly filter malicious DDoS traffic near its source. If we think on the challenges that such a cooperative defense system face, we can think in 4 different dimensions. First one is of a technical nature. We are dealing with the internet, which has heterogeneous networking systems. You have a lack of standards and protocols, and therefore a high complexity to deploy a cooperative defense and to operate, because those different systems, they are talking most of the time using different protocols and doing different operations. On a social aspect, you have the concern with the public image and also the confidentiality of the data. Service availability is something extremely valuable in the internet, and if you have this data being used against your public image, this can be huge loss for players. If we think on the economic aspect here, we have that mitigation attacks in a cooperative defense means that you are using the infrastructure of a third party, which also means that you are generating operational expenses for a third party. And this ideally should be covered by incentives. And the fourth and last point here is the legal aspect, in which you have different regulations across different regions. And all of those should be considered. We evaluated here 4 selected references as means of comparison, in which most of them aims to tackling the technical aspect, which is providing a solution that can make it easy or to reduce this complexity of deployment and operation of a cooperative defense. With a side note here to the IETF DOTS, which is a proposal by the Internet Engineering Task Force to create a standard. This is still an ongoing proposal. And we are attempting here with SC-Flare to create a solution in which we tackle all of those different dimensions for a cooperative defense. And Jumping here to the design of SC Flare, I do have to mention that it is intended to operate on a blockchain, on a permissioned blockchain, in which you can select the members that are taking part of this cooperative defense. Means that you have an initial level of trust to have those members. And the contract here regulates the operation between a target, the one that is under attack, and the mitigator, the one that would offer the attack, and starts with the target initiating the contract, defining some variables such as the offered funds. Then the mitigator can approve or abort being cooperative. Considering that the mitigator accepts, then the target can also abort, can still have time to abort the cooperative defense request or send the funds to initiate the contract. Then when funds are sent, they are locked by the contract, and then at this point the mitigator starts the first deadline in which it has a time to upload a proof. And by this upload a proof means that mitigator will upload a hash in which the target can fetch this proof off chain, and this data is not being put on chain, in which everyone can see how the mitigation service was realized. The next steps here, we have the rating, both the rating of the target, evaluating how the mitigator did the service, and this can go in different ways, and the mitigator as well can rate back based on those different branches of evaluation, can rate back the evaluation of the target. And then the protocol can complete in different ways. We have a special case, which is the case number 9, in which the situation can escalate. What happens in this case is when the mitigator uploads a proof and then the target is dissatisfied, and one rational behavior for a mitigator that did a service in which it considers was a fair service is to complain, and this makes the situation to escalate. So the funds are locked inside the contract, and you need a third party to decide on the situation. It's a situation in which it's not possible to be automated because there is no agreement between those two parties. As a preliminary evaluation of SC Flare, the goal here was to check the correctness, meaning that if we were able to provide all the functionality concerning the offering of incentives as well as tracking of reputation in an environment that is in a contract that can comprise the cooperative logic. And we were able to do that. We evaluated this protocol using Ganache, which is a blockchain simulator. We used the block time here of 5 seconds, simulated the reaction time of 1 second, and the deadlines of 5 seconds. In average, we have 32 seconds for the completion of the contract. Okay, for the considerations here, we provided SC Flare, which is a cooperative system that is decentralized and transparent, taking advantage of blockchain. And this provides you increased trust levels. It's not possible to solve the trust issue completely, but you can increase the levels of trust by increasing the transparency on the system. You can also provide financial incentives with reputation tracking in a system that has no single point of failure and is completely decentralized. The code is open source, available on the link below. And as the next steps, we are aiming to evaluate the more aspects of the system, for instance, performance of how those different mitigators can interact with each other. And this is the next step of the system. I'm open for questions. Thank you.